The universe is vast, ancient, and filled with secrets. For centuries, we have looked up at the night sky and wondered how it all began. We have built bigger and better telescopes, each one peeling back another layer of cosmic history. But even with our most powerful instruments, the earliest moments of the universe remain shrouded in mystery, like a story with its first chapter missing. That is, until now. The James Webb Space Telescope, or JWST, is not just another telescope. It is a time machine. It is designed to look further back into the past than ever before, to see the very first stars and galaxies switching on in the darkness. It is our new window to the dawn of time, and it is showing us things that are changing everything we thought we knew. Imagine launching a marvel of engineering, a giant golden eye, 1.5 million kilometers from Earth. Its mission is to capture the faint ancient light that has been traveling across the cosmos for over 13 billion years. This is the incredible task of the JWST. It is so sensitive that it can detect the heat signature of a bumblebee on the moon. This power allows it to see the universe in infrared light, which is invisible to our eyes but holds the key to unlocking the past. Light from the most distant objects has been stretched by the expansion of the universe, shifting it into the infrared part of the spectrum. The JWST is built to catch these whispers from the past, and the whispers it has recently heard are more like a roar. The entire world has been holding its breath, waiting for the discoveries that the JWST would deliver. Scientists, astronomers, and space enthusiasts alike have been eagerly anticipating the data that would stream back from this incredible observatory. Every new image is a postcard from a forgotten era, a glimpse into the cosmic nursery where the first structures of the universe were born. The telescope has already revealed stunning nebulae, detailed portraits of distant planets, and galaxies colliding in a cosmic dance. But its latest finding, announced in June 2025, goes right to the heart of one of the biggest questions in cosmology. How did the universe become the bright, transparent place we see today? What the JWST found has sent shockwaves through the scientific community. It is a story about something incredibly small, having an unbelievably big impact. It is a discovery that solves a long-standing puzzle about the transformation of the entire cosmos. The telescope has found a hidden population of tiny, ancient galaxies that were the true architects of the modern universe. These were not the giant, majestic galaxies we often imagine, but something much smaller and far more numerous. They were the unsung heroes of the early cosmos, and their story is one of power, transformation, and light. Get ready, because we are about to journey back to the very beginning. To understand why this new discovery is so important, we have to travel back in time, way back. Let's go to a period just after the Big Bang, about 13.8 billion years ago. In these early moments, the universe was a hot, dense soup of particles. As it expanded and cooled, protons and electrons came together to form neutral hydrogen atoms. This event created a kind of cosmic fog. The universe was filled with this thick, opaque gas which acted like a dense mist that blocked light from traveling freely. If you could have been there, you would not have seen any stars or galaxies. It was a dark, murky period in cosmic history, often called the Cosmic Dark Ages. This cosmic fog did not last forever, though. Something happened that changed everything. Over hundreds of millions of years, this opaque fog was cleared away, making the universe transparent. This monumental event is known as the Era of Reionization. It was like a cosmic sunrise, where the lights finally came on across the universe. The neutral hydrogen gas that filled space was zapped with so much energy that its electrons were stripped away, or reionized. Once the gas was ionized, light could finally travel unimpeded across vast cosmic distances. This is why we can see distant galaxies today. The universe became the clear, star-filled cosmos we know and love. But what could possibly have enough power to reionize the entire universe? This has been one of the biggest mysteries in astronomy for decades. Scientists had a few main suspects. One idea was that massive galaxies, the giants of the early universe, were responsible. Perhaps their sheer size and brightness produced enough powerful radiation to clear the fog. Another theory pointed to supermassive black holes, known as quasars, which are incredibly bright and energetic objects found at the centers of galaxies. Maybe their intense radiation was the key, or perhaps it was something else entirely, something we had not been able to see. The problem was that we did not have enough evidence to be sure. When we looked into the early universe with older telescopes, we could see some large galaxies, but there did not seem to be enough of them to do the job. They were too few and far between to have cleared the fog everywhere. Supermassive black holes were also rare in the early cosmos. It was a cosmic whodunit, and our detectives were missing the crucial clues. We knew the fog had cleared, but we could not identify the culprits. We needed a more powerful detective, one that could see the faint hidden objects of the early universe. We needed the James Webb Space Telescope. And now, thanks to the JWST, we have our answer. The culprits were not the giant galaxies or the powerful quasars we suspected. Instead, the telescope has uncovered a secret army of tiny star-forming galaxies. In a groundbreaking discovery, astronomers have identified 83 of these minuscule galaxies from a time when the universe was only about 800 million years old. These galaxies are incredibly small, even by cosmic standards. To give you some perspective, you would need to bundle together anywhere from 2,000 to 200,000 of these tiny galaxies just to equal the mass of our own Milky Way galaxy. They were the cosmic underdogs, previously too faint and distant to be detected. Despite their small size, these galaxies were incredibly energetic. They were what astronomers call starburst galaxies, meaning they were forming new stars at a furious rate. Think of them as cosmic factories, churning out massive, hot, bright stars at a pace far greater than our own galaxy does today. This frantic star formation produced an enormous amount of high-energy ultraviolet light. It was this UV light that was the secret weapon in the fight against the cosmic fog. The light was so powerful that it had the ability to knock electrons off the neutral hydrogen atoms, ionizing the gas and making it transparent. So, why were these small galaxies so much better at this job than their larger cousins? The answer lies in their size. Because they were so small and less massive, they had less of their own neutral gas to hold on to. In larger galaxies, much of the UV light produced by young stars gets trapped and absorbed by the galaxy's own gas clouds before it can ever escape. But in these tiny galaxies, the UV light could escape much more easily. They were like leaky buckets, spilling their powerful radiation out into the surrounding intergalactic space. This leaky nature was the key to their universe-altering power. This discovery, announced at the 246th American Astronomical Society meeting, provides the strongest evidence yet that these numerous small galaxies were the primary drivers of reionization. While one tiny galaxy could not do much on its own, there were likely thousands or even millions of them scattered throughout the early universe. Together, their combined UV output was more than enough to burn away the cosmic fog and fundamentally renovate the entire cosmos. They were tiny, but they were mighty, and their collective effort changed the universe forever, paving the way for the stars, galaxies, and planets we see today. Now let's dive a little deeper into this incredible transformation called the era of reionization. Imagine the early universe as a vast, dark room filled with a thick fog. In this room, someone starts lighting tiny little candles. At first, each candle only illuminates a small bubble of space around it, but the rest of the room remains foggy. This is what the first galaxies were doing. Each one was a source of powerful UV light, and this light started to carve out bubbles of clear, ionized gas in the surrounding cosmic fog of neutral hydrogen. Inside these bubbles, light could travel freely, but outside them, the universe was still opaque. Over time, more and more of these tiny candles were lit. As thousands of these small starburst galaxies ignited across the cosmos, the bubbles of clear space they created began to grow. Eventually, these bubbles started to overlap with one another. A bubble from one galaxy would merge with a bubble from a neighboring galaxy, creating an even larger region of transparency. This process continued for hundreds of millions of years. It was not an instantaneous event, but a gradual, cosmic-scale renovation project. The universe was slowly, bubble by bubble, being cleared of its primordial fog. The energy needed for this task was immense. The UV light had to be powerful enough to strip an electron from a hydrogen atom, a process that requires a specific amount of energy. The hot, massive stars born in these tiny starburst galaxies were perfect for the job. They burned brightly and died young, and during their short lives, they flooded their surroundings with exactly the right kind of high-energy photons. Because these galaxies were so numerous and so leaky, they effectively flooded the entire universe with this ionizing radiation, ensuring that no corner of the cosmos was left untouched by their transformative light. This discovery finally solves the long-standing debate among astronomers. For years, the numbers just did not add up. The few large galaxies and quasars we could see from that era were not enough to account for such a widespread change. It was like trying to light up a giant stadium with just a few big floodlights. There would still be plenty of dark corners. But the discovery of this huge population of tiny galaxies changes the calculation completely. It is like finding out the stadium was actually filled with thousands of people, each holding a bright torch. Their combined light would easily illuminate the entire space, leaving no shadows behind.